How's it going, guys? Today in this video, we're going to be going over Module 12.3, Day 1, Solving Radical Equations. Well, not Day 1, it's really the only day of 12.3. We're going to be going over it, and we're going to be talking about how to solve radical equations. So, a radical equation contains a variable within a radical or a variable raised to a non-integer rational power. To solve, we're going to square both sides, and then we're going to solve the resulting equation. Because opposite numbers have the same square, you may introduce an extraneous solution. And remember, an extraneous solution is a solution that we get when we solve for x, but it doesn't actually work in the context of our original equation. And because of that, we always have to check our solutions when we're solving with square root functions. So on number 1, we have 2 plus the square root of x plus 10, and that equals x. So whenever we're solving for a radical or a variable underneath a radical, we always want to isolate the radical and let it be by itself. It's just going to make solving it much easier. So we're going to subtract 2 on both sides, and we get the square root of x plus 10 equals x minus 2. And then we're going to square both sides so we can get rid of the radical. So the square root and the square cancel out, and we're left with x plus 10 on the left side. And on the right, we have x minus 2 squared. That's a perfect square. So we end up getting x squared minus 4x plus 4. Or if you don't remember your factoring patterns, you could just FOIL out x minus 2 times x minus 2, and you'll get the same thing. So now we're going to add like terms. So I'm going to minus x and minus 10 to the other side, and I get 0 equals x squared minus 5x minus 6. So I see that I have a quadratic, and that's already set equal to 0. And that's exactly what we want. Whenever we have a quadratic, we want to set it equal to 0 so we can actually solve it by factoring. So we're going to factor out x squared minus 5x minus 6. So we're going to look for factors of negative 6 that add up to give you negative 5. And in this case, that's going to be negative 6 and positive 1. And that all equals 0. Negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So we factored out our quadratic, and now we're going to set each factor equal to 0, and we get x equals 6 and x equals negative 1. So we have our 2 possible solutions of x. And what we're going to do now is we're going to take each one and plug it back into our original equation, and we're going to see if it actually makes sense. So we have x equals 6. We're going to solve for that one first. So we have 2 plus the square root of 6 plus 10, and that should all equal 6. We're going to solve this out. 2 plus the square root of 16 equals 6. The square root of 16 is 4. So we get 2 plus 4 equals 6. So we get 6 equals 6, and that's correct. So x equals 6 will be one solution to this problem. Next, we're going to do the same thing for x equals negative 1. We're going to plug it back into the equation, and we get 2 plus the square root of negative 1 plus 10 equals negative 1. Negative 1 plus 10 is 9 to the square root of 9. And the square root of 9 is going to be 3. So we have 2 plus 3 equals negative 1. And the 2 plus 3 is 5. And 5 does not equal negative 1. That doesn't make sense. So x equals negative 1 cannot be a solution. So our only solution is x equals 6. So let's go on to number 2. On number 2, we have x plus 6 to the 1/2 minus 2x minus 4 to the 1/2, all equals 0. So these are rational exponents, and we're going to change them into radical expressions. Remember, anything raised to the 1/2, that's the power over the root. So it's a power of 1 to the root of 2, and the root of 2 is just the square root. So it's the square root of x plus 6 minus the square root of 2x minus 4, all equals 0. So we have two radicals, and like I said before, we always want to isolate our radicals. So we're going to move the square root of 2x minus 4 to the other side. So we get the square root of x plus 6 equals the square root of 2x minus 4. So now that we isolated both our radicals, we're going to try to get rid of those radicals. And we're going to do that by squaring both sides. Square root, if you're going to try to get rid of the square root, you square that square root. So we cancel those out, and we have x plus 6 equals 2x minus 4. We're going to add like terms. So I'm going to add 4 over. X plus 10 equals 2x minus x. 10 equals x. And that's going to be our solution for number 2. Or it's not our solution yet. We have to double check. Sorry about that. It could be an extraneous solution. So we're going to plug in x equals 10 into our equation, which was x the square root of x plus 6, so 10 plus 6, minus the square root of 2 times 10 minus 4 should all equal 0. We should always check our solutions whenever we're dealing with square roots. So the square root of 10 plus 6 is 16, minus the square root of 20 minus 4, which is also 16, and that equals 0. We have the same number here, subtracted from each other. So the root of 16 minus the root of 16 is just going to be 0. So we get 0 equals 0. That makes sense. 0 does equal 0. So that means x equals 10 is our solution. And we double checked it by plugging it back into our equation, and what we got made sense. All right, let's go on to number 3. On number 3, we have x plus 5 to the 1/2 minus 2 plus 1. So what we're going to do is we're going to change that rational exponent into a radical expression. So we have the square root of x plus 5 minus 2 equals 1. We'll add the 2 over. And then we're going to square both sides. So the square root and the square cancel out. So x plus 2 equals 9, or x equals 7. Oh, okay, so I put 2 for some reason inside the square root, and you looked a little wrong. It should be x plus 5. So let's back up a little bit. So square root of x plus 5, there we go, equals 3. And this is what we're going to take the square of. The square root and the square cancel out. So we get x plus 5 equals 9. We're going to minus 5 to both sides, and we get that x equals 4. That's a possible solution. So we're going to plug it back into our original equation. So when we do, we get the square root of 4 plus 5 minus 2 equals 1. The square root of 4 plus 5 is just the square root of 9 minus 2 equals 1. 3 minus 2 should equal 1. And it does. 1 equals 1. That makes sense. So x equals 4 is our solution. So let's go on to the next page. Okay, so now we're going to talk about solving. It says square root, but it should say cube root and 1/3 power equations. So we can solve other radical equations by raising both sides to the index of the radical. And if you forgot what an index is, if we have something like the cube root of x plus 7, that 3 inside that little v part of the radical, that's your index. Or that's what's going to be, or in other words, it's your root. So on number 1, we have the cube root of x plus 2 plus 7 equals 5. So we're going to subtract 7 on both sides, and we get the cube root of x plus 2 equals -2. So we're going to raise both sides by the index to get rid of that radical. In this case, the index for the root is 3. So the cube root and the cube cancel out. And we have x plus 2 equals negative 2 to the third power, or negative 8. So now we're going to minus 2 on both sides, and we get that x equals negative 10. And I know in the example it says check for extraneous solutions, but since we're dealing with cube functions and cube roots, we don't actually have to check for extraneous solutions because every cube root is, and it's not individual, but it's unique. You're not going to have two of the same number giving you the same cube. Unlike with square roots, where 2 and negative 2 both give you 4 when you square them, 3 and negative 3 will give you two different functions when you cube them. So every cubic function is unique. So on to number 2. We have the cube root of x minus 5, and that equals x plus 1. So we're going to cube both sides to get rid of that cube root. The cube and the cube root cancel each other out. So we have x minus 5 equals x plus 1 cubed, or really just x plus 1 times x plus 1 times x plus 1. So we're not going to waste a lot of time actually trying to FOIL this out. You should know how to FOIL out already. So x plus 1 times x plus 1 times x plus 1. That's going to give you x cubed plus 3x squared plus 3x plus 1. Just multiply them all together, FOIL it all out, and you get x cubed plus 3x squared plus 3x plus 1. And now we're going to add like terms and add 5 and minus x to the other side to give us 0 equals x cubed plus 3x squared plus 2x plus 6. So we see that we have 4 terms. So whenever we see 4 terms and we're trying to factor it out, I'm always going to think about factoring by grouping first. So that's what I'm going to try. I'm going to group up the first 2 terms and group up the last 2 terms. And I'm going to take out the GCF. The GCF of x cubed plus 3x squared is x squared. So I'm left with x plus 3. And the GCF of 2x plus 6 is 2. And I'm left with x plus 3 as well. And since what's left over is the same, we factor by grouping works. So we get 0 equals x squared plus 2. What's outside the GCFs? Multiply with x plus 3. So I'm going to set each factor equal to 0 now. Since this whole thing already equals 0, I'm going to set each one equal to 0 and solve for x. So an x squared plus 2 equals 0. I get x squared equals negative 2. And we get the square root of negative 2, or plus or minus the square root of negative 2. So the problem here is that we don't want any imaginary answers. So we get an imaginary solution with x squared plus 2 equals 0. So that's not going to work out. We can cross it out. But for x plus 3 equals 0, we get that x equals negative 3. So that's going to be our solution for number 2. All right, for number 3, we have 2 times x minus 50 to the 1/3 equals negative 10. So we want to isolate the radical, or in this instance, the rational exponent. Remember, a rational exponent will become a radical anyway. So when we do, we get x minus 50 to the 1/3 equals negative 5. We're going to take the cube root of both sides. We're not taking the cube root, sorry, but just rewrite the left side as a cube root. And now we're going to get rid of that cube root by cubing both sides. The cube root and the cube cancel each other out. And we get x minus 50 equals negative 5 cubed, which is negative 125. And we just add 50 to both sides. And we get that x equals negative 75. And that's going to be our solution for number 3. Now to number 4. So we have 2 rational exponents, and that's equal to 0. I'm going to change them both into radical expressions. So I get the 4th root of 2x minus 6 minus the 4th root of x plus 4. And that all equals 0. So I always want to isolate my radicals. So I'm going to move the fourth root of x plus 4 to the other side. And when I do, I get the fourth root of x plus 4. So now I'm going to raise both sides by the index. In this case, my index or my root is 4. So I raise both sides to the fourth power to get rid of these radicals. And when I do, I'm left with 2x minus 6 equals x plus 4. All that's left is to solve for x. So I get 2x equals x plus 10 minus x. And I get that x equals 10. And that's going to be my solution. All right, so let's keep on going. We have a couple of work problems to go through. So for number 1, we're told the speed s in miles per hour that a car is traveling. So right there from the beginning, we're told that s stands for speed. So the speed in miles per hour that a car is traveling when it goes into a skid can be estimated by using the formula s equals the square root of 30 times f times d. We're told f is the coefficient of friction, and d is the length of the skid mark in feet. So we're told that after an accident, a driver claims to have been traveling the speed limit of 55 miles per hour. So we're told that s should be 55. And then we're told the coefficient of friction under the conditions at the time of the accident was 0.6, or that f equals 0.6. And after that, we're told the length of the skid marks is 190 feet. That's our D. D stands for our skid marks. So D equals 190. So 1A is asking us, is the driver telling the truth about the car's speed? So if he is telling the truth about the car's speed, we have all the variables. All we need to do is plug them all in and see if our S of 55 does equal the square root of 30 times 0.6 times 190. If 55 does equal that square root, then he's telling the truth. So we're going to solve this out. So the square root of 30 times 0.6 times 190, or rather what that all equals underneath the radical, is going to be 3,420. So 30 times 0.6 times 190 is 3,420, and the square root of 3,420 is going to be about 58.5. And 58.5 is not 55, so that tells us that the driver is lying. He's not telling the truth, because if he was, we would have gotten 55 equals 55, which it didn't. We got 58.5. So the answer is no. And then for 1B, we're told to use the formula to find the length of a skid mark at a speed of 55 miles per hour. So we're told that S equals 55 in this problem, and the coefficient of friction, or F, is going to stay 0.6, and we're going to solve for our D. We don't know what the length of the skid mark would actually be when S is 55, so we're going to plug in our S and our F and solve for D. So we have 55 equals the square root of 30 times 0.6 times some D that we don't know. So we're going to multiply this all together, and we're going to solve for D. So 30 times 0.6, that gives us 18. So you have 55 equals the square root of 18D. And we need to get rid of that radical since our variable is underneath that radical. So we square both sides. 55 squared is 3025. And the square root and the square here cancel out. And we're left with 18D. All we have to do now is divide 3025 by 18. And when we do, we get that 168 equals D. Just divide both sides by 18 over here, and you get D equals 168. And that's what our answer is going to be for 1B. 1C is not in your notes. We're not going to worry about that. Because you're just comparing the distance of 168 to 190, it's not much really to do there. So we're going to go on to number 2. Number 2, we have a construction problem. It tells us that the diameter D, inch of a rope needed to lift a weight W in tons, is given by D equals the square root of 15W all over pi. So 2A asks us how much weight can be lifted with a rope with a diameter of 1 inch. So we're asked if D is 1, what's W going to be? So 1 is going to equal the square root of 15W all over pi. So we're going to solve for W. We're going to multiply both sides by pi. We get pi equals the square root of 15W. And we're going to square both sides. And pi squared is going to give us 9.86. And the square root and the square cancel out. So we have 9.86 equals 15W. Divide by 15 on both sides. And we get that W equals 0.66, or really, W is approximately 0.66. We're just going to round to the 100th place. And that's going to be our answer. W will be approximately 0.66. So now we're going to use the formula for the diameter as a function of weight and solve for the weight given the diameter. So I'm just saying that we want to solve for our inverse of D. So we have D equals the square root of 15W all over pi. And we want to solve for W equals, or solve this for W, or in other words, we're solving for our inverse. So we're going to multiply both sides by pi. So we get pi times D equals the square root of 15W. And then we're going to square both sides to get rid of that radical. And when we do, we have pi times D all squared equals 15W. And then we'll divide by 15 on both sides. So we can isolate the W. So we get that pi times D squared all over 15 will equal W. So that's our inverse of D and the answer for B. All right, so that's the video, guys. That's all there is to it. Hopefully it helps.